I'm here in our Coastal Research News and Education Center. We'll be coming to you from here periodically in this class. Let me just go over a couple of things that we're going to be doing in terms of how we're going to approach the whole subject of futures forecasting. There are several different ways that we can go here. And what we've chosen to start with is to lay out some time parameters for you. Paul Schmidt is going to be co-instructor, of course. Future telling, forecasting, crystal balls. Here's a crystal ball, of somebody forecasting the future has been around as long as civilization and human beings. What we're going to do here is basically use these three time frames, micro, macro, and meta, which is the present, immediate future, and a little bit more advanced future. There are also some other ones that we're going to talk about in a couple of minutes, but we don't need to do that right now. So if you look at the micro time parameter, we're talking about the next 6 months or 2 years. We're talking about, if you look at this little drawing here, we have today here, then we have a very small pink arrow that takes us into tomorrow and next year and 2 years from now. And the distance between today and when we're forecasting is very short. There are a small number of variables within the timeline, so the timeline doesn't contain a whole lot of variables because it's relatively short time prediction. And there should be a relatively high accuracy of prediction. The length of time in the short time frame, we should be able to predict fairly well. Now, take a look at that and think about perhaps, let's say, predicting hurricanes. I think, depending on when you're watching this, we are beginning to talk about the next hurricane season. And we're going to be saying, well, this is going to be less active, more active, or an average hurricane season. And think about the accuracy rate of predictions of hurricanes that we've had in the past. Some of them haven't been very good, and that's really just a 12-month prediction. So even on the short time frame, that doesn't necessarily mean that the predictions are very accurate, but they should be more accurate. If you go in the macro time parameter, we're talking about a decade, decennial projections. There are more proximate variables. The width of the timeline is a little wider. That means there are more variables in here in this pink timeline. And there should probably also be somewhat less accuracy in prediction because of the length of the timeline. Not only are there more variables, but as you spread it out, you get higher uncertainty components predicting, let's say, the hurricane season or other things over a 10-year time frame gets a little more tricky. If you go to a 25 to 100-year projection, you have a very large number of variables here in this huge pink timeline and a much, much longer period between today over here in the black box and 50 years from now or 40 years from now. So if we're projecting to 2040, which I like to do, we have to have much more sophisticated ways of doing that because the challenge is much greater. There are conditions that are greater. If you look at this particular, down here is where we are right now. You see this is actually a little model of a solar powered little vessel. And we want to project in a short time frame here where that yellow line is, and you lay out a course. We're going to go from here to a certain destination. This short course you can navigate fairly easily. If you want to project from where we are now to where this vessel finally arrives up there, you've got a much longer time frame. And if you get any errors in here in your navigation, you have more tides, you have winds, you have potential storms, you have all kinds of things that may affect the direction of the navigation. So if you want to project over a long course, you're going to go from one place across the Pacific Ocean, the margin of error gets much greater. And if you get it wrong, then this happens. Instead of arriving up here, you end up getting to the edge of the earth and falling over, so to speak, in the traditional view of the flat earth. So I hope that that helps you to remember that long-range projections are essentially subject to a much greater challenge in the distribution of your variables and in the model that you build. So let's go on to another thing that might be of interest, and that is that you need to think over the next weeks as we do this course, what are the major distortions that could either have us overestimate or underestimate the risks to coastal zones and to oceans? And I need you to really think big. This is a class in which thinking small doesn't get us very far. You need to think really big. What are some of the things that could happen over the trajectory of our projections here that could significantly alter the predictions on whatever it is? Some of you are more interested in overfishing, and some of you are more interested in global warming or climate change, and some of you are more interested in pollution and contamination, land use, and there are a whole series of coastal issues, of course, that you may be interested in. What are the things that might distort those predictions? And that's something that I want you to think about as we develop this class. So thinking big is going to be rewarded. Thinking about the complexity of predicting is going to be a very important part of what we do. And then I'll come back in the next little segment and I'll talk about some other factors that go into the whole science and art of predicting that will be useful as we enter this course and this discussion. So I'll see you in a little bit.